As you can see, question number 6 is kind of heavy. So what we are given is the x and y equations, which are these right here. What we are supposed to do is supposed to come all the way down here and find out what the derivative is and plugging in 2. So right here shows the work to find all the derivatives, but we'll come back to that. Basically, we have to use this equation right here, which is given right here, for the x values and y values, and find the acceleration at time 2. So first we have to find the velocity or the speed of x and y. So when we find the speed of x, we have to find the derivative of this equation, which is right here. We find the derivative by using the product rule. So in this case, we'd be using the f of x is t and g of x is e of negative t. When we apply the product rule, we get this as our value for the speed of x, or the derivative of x. Then we have to also find the derivative of y. We don't necessarily have to use a product rule for it, but we just use basically the natural log methods, like the derivative of natural log, and we find out that it's 1 over 2t. We also have to multiply that by the derivative of what is being on the inside here, and it comes out as 2 over 2 of t plus 6, and that basically includes the chain rule as well. And so we come up here and we now know that these are derivatives of x and y, or the velocity vectors. Now we have to find the acceleration vectors. We know that the acceleration of x, or the double derivative of x, is right here. We use that again through the product rule, which is established down here. We just have to find the derivative of this value, and then we actually apply the product rule to this value right here, to the negative t, e to the negative times e to the negative t. In this case, f of x is negative t, g of x is e of negative t. Plug that in, we figure out that it is negative 2e to the power of negative t plus t to the times e to the power of negative t. That is not supposed to be e of t. Oops. And so we move on to the next one. Again, applying the same rules, same methods. We come out as negative 4 divided by 2t plus 6 squared. Or actually, that was right. Either way, it's right and it works. And then we now have velocity vectors, or I'm sorry, the acceleration vectors, which are right here. And now we have to find that in relation to time 2. So basically we plug in t. These equations actually cancels out. This one ends up being negative 1 over 25. So in this case, the value of each velocity is going to be 0, negative 1 over 25. So that would be our answer right there when finding the velocity value at time t. 2 equals 2.